Hello and welcome to this tutorial. Today I'm going to go over the steel bolt group analysis calculator that we have recently added to the analysis calculators in ClearCalcs. Let's check it out. First, we're going to go over the references and assumptions. For reference, we are using the AISC Steel Construction Manual 5th edition. And for assumptions, we are only assuming in-plane shear and moment loads. They're the only ones that can be entered as force inputs. All bolts in the pattern have a uniform area. This analysis calculator analyzes symmetrical and unsymmetrical bolt groups. The centroid of the bolt group is automatically recalculated once the user inputs the X and Y coordinates. We're going to talk about these assumptions further as we're doing the calculations. Now, the first thing that we're going to see is going to be the bolt pattern coordinates. Here you can input as many bolts as you'd like and see how they look like, the arrangement on your right in this diagram. We're going to add 2 more bolts on top of these bolts, and it's going to be around 100 millimeters above. So let's start. For the first one, we're going to have -75 and 250, and we're going to have +75 and again 250. As you can see here, what ended up happening is that the red cross indicating the center of gravity moved up, which means that the center of gravity was recalculated as we entered these 2 bolts, the coordinates of these 2 bolts. Therefore, you don't really necessarily need your 0, 0 coordinates to be at your center of gravity. They can be anywhere you'd like them to be, but the center of gravity is going to be calculated with respect to that 0, 0 coordinate that you select in the beginning. Once you're happy with the coordinates, if you scroll down, you're going to see the applied loads and eccentricities. The first thing that you're going to enter is your applied vertical load. If we go to the debug image, we're going to see that PA is the in-plane shear load that is acting on your bolt group. After that, we have to enter the X coordinate of the applied load. Basically, what we really need to know is that where is this PA located with respect to the 0, 0 coordinates. This means that your PA is 75 millimeters away from your 0, 0 coordinates. After that, what this template is going to calculate is your horizontal eccentric distance from the centroid, so your E. This E is going to help us calculate the moment, the eccentric moment that is applied on the furthest bolt in the bolt group. These are the most critical inputs that you have to input in this calculator. The rest is just the calculator doing its thing. Now you can see that in this section, we're calculating the shear loads on an individual bolt furthest away from the centroid. First, what we're going to do is calculate the direct vertical shear on the bolt. And as you can see, this is your applied shear load divided by your number of bolts. And then we're going to calculate the vertical shear force and the horizontal shear force on the bolt due to eccentricity. After that, we're going to calculate the sum of the vertical shear and the horizontal shear acting on the bolt. After all of these things are calculated, if you move up, you're going to, in the summary section, you're going to see the maximum resultant shear force, which is the vector summation of your vertical and your horizontal forces that we calculated in the past section. That was all it for me today. If you have any further questions, please let us know through help@clearcalcs.com. I hope you enjoyed this tutorial. Thank you so much. Bye.